Hello everybody, and welcome to your intro video to circle geometry, where we will be looking at tangents and properties of chords in a circle. So let's get some definitions out of the way first. I don't think we need to cover exactly what a circle is, but if you're looking for the definition of it, it's a set of all points in a plane that are equidistant from a given point called the center of the circle. Okay, center of the circle in your Math Makes Sense workbook is usually identified by the letter O. Okay, so that would indicate the center. Radius, this again should just be review for you guys, is the distance from the center to a point on the circle, and the diameter is the distance across the circle through its center. And just to get a visual, here we go. So radius is half the distance across the circle to the center point, and the diameter is the full way across. So if you know the diameter, you can just chop that number in half and you would have the radius. For example, if the diameter was 10, our radius would be 5. Chord, this might be a new definition for you. So chord is just essentially a line that connects points on a circle, okay? And the endpoints are on the circle. So you can see here line AB is a chord, okay, because it connects 2 points within the circle. A secant, this is a line that intersects a circle in 2 points, but the endpoints aren't necessarily on the end of the circle here, okay, so it kind of keeps going. Don't really need to know that for the first 2 sections of your math book, but there it is anyway. Okay, the other big term we need to be familiar with is the tangent. So the tangent is just a line in the plane of a circle that intersects the circle in exactly 1 point. And what that looks like is just a line like ST here that just kind of touches the circle, okay, in 1 point. The point of tangency, okay, that's actually the point where the tangent line intersects with the circle, okay? So this is the tangent line, and the point in which it touches the circle here and intersects, that's called the point of tangency. So let's look at a little example here to refresh our definitions. So line AH, okay, and the line is signified by this line over the 2 letters here. So let's find AH, okay? Well, that looks like a tangent to me. Line EI, that would be the diameter, so EI across here. Line DF, it connects 2 points on the circle, so that would be the chord in this case. And then line segment CE would be the radius. Okay, so a perpendicular tangent theorem basically states if a line is tangent to a circle, then it's perpendicular to the radius drawn to the point of tangency. And all that means here is, here's my tangent line, okay? If I draw a point from my center to that point of tangency, it is perpendicular to that to the tangent line, okay? So this would be a 90-degree angle, and this would be a 90-degree angle. Alrighty. So yeah, if I is tangent to circle Q at P, then I is perpendicular. This is just a symbol for perpendicular to PQ. Okay, so this is just saying that these are perpendicular lines. So in a plane, if a line is perpendicular to a radius of a circle at its endpoint on the circle, then the line is tangent to the circle. Okay, so that's just reinforcing what I said. We've got a perpendicular line here, therefore this line must be tangent. Okay. We're going to move on now and look at some examples in your textbook or your workbook. Okay, let's look at an example here. This is from page 319 in your Math Makes Sense workbook. So, in a triangle, it's important to remember that the total of all the angles added together, so you have 3 angles in a triangle, the total of these guys must add up to 180 degrees. Okay, so no exceptions there. It's always going to be 180 degrees. It doesn't matter if it's an isosceles, a scalene, a right triangle, it doesn't matter. So when we have a tangent here and a radius going to the center, we know that this line is perpendicular, okay? So therefore, we know that this line is actually, this angle is actually a right angle. So angle OCD would be equal to 90 degrees, okay? We could also write this angle as DCO. And when you're identifying angles, it's important that the middle letter is the angle itself, okay? These other two signify which line segments we're going to look at here, okay? So I know I'm looking at OC and DC, but I know that we're referring to angle C in this case because it's in the middle here, okay? So always remember that. So now, we know that this is 90, this is 65, and that the total is going to be 180, so therefore we can solve for x by saying 180 degrees, that's going to be our starting point always, minus 90 minus 65. So we're just plugging in our known values here, and 180 subtract 90 is 90, and 90 minus 65 is going to leave us with an angle measurement of 25, excuse my writing, degrees. Okay, and that's it. Let's look at another example. This next example comes from page 322 in your Math Makes Sense 9 workbook. So what we have here is a triangle, and we're asked to find OQ. Alright, so this should look very familiar to you because we've covered this before. This is Pythagoras' theorem, okay? And if you remember Pythagoras' theorem, it's essentially, h squared equals a squared plus b squared, meaning your hypotenuse squared is the sum of the two legs squared, okay? So, it doesn't matter that this is inside of a circle or not, okay? We just know some known values here because we know that this is going to be our right angle here because we have a tangent here, which our point of tangency is right there, and then we have a perpendicular line here from O to P, which is our radius in the circle, okay? And that's a known value of 4 centimeters, okay? So we know the value of this leg, we know the value of this leg. All we need to find is our hypotenuse value. And remember, the hypotenuse, if you draw an imaginary line across from the right angle, you will hit your hypotenuse. And your hypotenuse is always the biggest or the longest leg in the triangle. Okay? So, angle OPQ, so OPQ equals 90 degrees. We know that from our tangency laws, okay? So that's a right angle, so we can apply Pythagoras' theorem here. So all we're going to do is square the two legs, so 4 squared plus 6 squared. And remember, when we're squaring a number, we're just multiplying it by itself. So 4 squared does not mean 4 times 2, it means 4 times 4, which gives us 16. 6 times 6 gives us a sum of 36. And now we just simply add those squares together. So 36 plus 16 is going to give us 52. Okay, now we want to solve for x. We have x squared here. So what we have to do is perform the inverse operation of x squared. The inverse operation, or opposite operation, is to take the square root. Okay, so this x squared now becomes just simply an x. Okay, and we just take the square root of 52. So you're going to use your calculator for that. So you take square root of 52. And you're going to end up with an answer. Oh, sorry, let me just plug my 52 in here under the square root symbol. And you're going to get an approximate answer of 7.2 centimeters. Okay? And that, of course, kind of makes sense in here. If this was a number like 50, that would look kind of strange with these being 4 and 6. And, of course, I'm noticing also that the 7.2 is greater than the two legs because it has to be. Okay? And let's move on to another example. Alrighty, so what I want to talk about now is just a property of chords. Let me get this up here. Okay, so in a circle where you have center O and a chord across here, AB, okay, if you draw a line, almost like you're going to draw a radius, you draw a line towards it. Okay. If it bisects this line AB, then it basically is going to cut it in half. Okay, so OC is going to be perpendicular to AB, and that's going to mean that AC is the same length as AB. Okay, so CA and CB are the same. Okay, I was calling it AC, BC, same thing. So AC and CB are the same distance because it's chopped in half by this line right here. Okay, and these are of course perpendicular lines, which means that these are right angles here. So OCB would be a right angle. Okay, so let's look at an example where this would apply. So in this example down here, it says O is the center of the circle. Find the length of chord AB. Okay, so here we have a right angle. These lines are perpendicular. OC is perpendicular to line AB, which means it's also perpendicular to AC and CB. Now, so let's just look at the big picture here. We want to find AB. So we're trying to find this line here. What I can conclude from looking at this is that we can use Pythagoras' theorem because this is a right angle. Okay, and we know two sides. We know the hypotenuse and we know one leg. That means we can calculate this leg. We can calculate CB. And we know that CB and AC are equal. So what we need to do is find CB and double it. Just multiply it by 2 and that should give us AB, our full length across here. Okay, so to do that we use Pythagoras' theorem, which is h squared equals a squared. Again, excuse my writing please. It's hard to do this with the mouse. So we know our hypotenuse is 10 squared. And this is going to be a squared, we'll call 6 squared, plus our unknown, which I'll just call x squared. Alright, so all we do now is solve. So 100 equals 6 times 6 is 36, plus, oops, this should be a plus sign here, plus x squared. We want to solve for x squared, so we need to isolate it. So what we do is take away 36 from this side, which means we have to take away 36 from that side. Okay, so we'll have 100 subtract 36 on our left hand side of the equal sign, so that's going to give us an answer of 64. And on the right side we subtracted 36, so we're just going to be left with x squared. So when we want to solve, all we do is take the square root of 64, and 8 times 8 is 64. So 8 is going to be equal x. Okay, that doesn't mean we're done, because x would be indicated by here. We need to find the full length across, so all we're going to do is double it. So we just say 8 times 2, and that's going to equal 16. So 16 would be our final answer. Okay, and again, that's in your Math Makes Sense workbook. You can check that out, and come see me if you need any extra help, guys. That's it for this week. Thank you.